Okay, so before we take a look at the math lab for the trig identities hexagon, I just want to walk through a simple trig identity so you get a feel for why this hexagon is so powerful. So the identity that we want to verify is that the cosine of x is equal to the sine of x divided by the tangent of x. And when you're verifying an identity, that just means you want to show that one side is equal to the other. And you usually start with the more complicated side. So we'll start on this side with the quotient and show that it equals the more simple side. So I could write this sine of x divided by tangent of x this way, that sine of x divided by tangent of x, and that just makes it a little bit easier to work with my tangent of x because I know that tangent is defined as the sine over the cosine. So then I would have sine of x divided by, and then I'm replacing tangent of x with its identity, the quotient identity, which is sine of x divided by cosine of x. That's what tangent is equal to. And when you divide fractions, you multiply by the reciprocal. So then we would have the sine of x times, and then the reciprocal would be cosine of x divided by sine of x. And this sine of x is over 1. So when we cancel then the sine of x out, we're left with just cosine of x. And that shows that the sine of x divided by tangent of x is in fact equivalent to the other side that we started with, the cosine of x. And that's a process called verifying a trig identity. Now, some identities, it's not worth going through all of this, right, if you just need to remember it quickly to use it. So that's what this math lab is for, is to teach you a memory trick with this hexagon for coming up with identities really quickly when you need them. So to build this hexagon, we're going to start by putting a 1 in the center. That's step number 1 here on the math lab. Draw the hexagon, put a 1 in the center. Then we're going to go to step 2, write tangent on the farthest left vertex. So from the 1, we go all the way to the left. That's where we're going to write tangent. And then we're going to go ahead and use the quotient identity to go around the circle here, or the hexagon. So tangent is equal to the sine divided by the cosine. Okay, and then step number 4 is to fill in the rest with reciprocal identities on opposite vertices. So if you recall, the reciprocal of tangent is the cotangent. So opposite tangent, I'm going to write cotangent. The reciprocal of sine is cosecant. So opposite from sine, I'm going to write cosecant. And then the reciprocal of cosine is secant. So opposite vertex from cosine, I write secant. And that's how we set up the trig hexagon for remembering identities. Now, the quotient identities you can get from this hexagon just by going along consecutive vertices in either direction. So we said that tangent is the sine divided by the cosine. We could also say that the sine is equal to the cosine divided by the cotangent. So sine of x is equal to cosine divided by cotangent. Okay, then the cosine would be equal to the cotangent divided by the cosecant, because those are the next two consecutive vertices. So cosine of x is cotangent of x divided by cosecant of x. Okay, then if I look for the cotangent of x, right, that's here, cotangent of x would be equal to cosecant of x divided by the secant of x. Oh, whoops. What was I doing? Cotangent is cosecant divided by secant. There we go. And then the cosecant would be next to consecutive vertices. So cosecant is secant divided by tangent. And then secant, next to consecutive vertices, tangent and sine. So the secant of x is the tangent of x divided by the sine of x. And we just got 6 quotient identities just by going clockwise around that hexagon. Now we can do the same thing going counterclockwise around the hexagon. So we'll start at cosine of x at this vertices, and now we're going to go the other direction. So cosine is sine divided by tangent. And then sine is tangent divided by secant. Tangent is secant divided by cosecant. Okay, then back here at the next column, secant would be the cosecant divided by the cotangent. And then the cosecant is the cotangent divided by the cosine. And then the last one, cotangent, is cosine divided by sine. Okay. And now we have 12 quotient identities that we came up with just by going clockwise and then counterclockwise around that trig hexagon. Okay, next we're going to take a look at the reciprocal identities, which we already learned these in previous lessons, but just to point out how they relate on the hexagon, right? Our sine is 1, there's that 1 in the middle, divided by the cosecant. That's down here. So the cosecant, if we use that same pattern, the cosecant would be equal to 1 divided by the sine. Okay, then on our cosine vertex, cosine is 1 divided by the secant. And then secant going the opposite direction, the secant of x is equal to 1 divided by the cosine of x. Okay, and then our tangent is 1 divided by cotangent. And then the last would be cotangent equals 1 over tangent of x. Okay, and those are the 6 reciprocal identities that we can get from the hexagon by going through the diagonals.